Hello, so today we're going to look at the database approach and we're going to describe the features of a relational database and the theoretical structure of the database. So, introduction now. So a database is not simply a collection of data, okay, because data has to have integrity, it has to have knowledge, it has to have meaning and context. Okay, so it has to have all of those things. So it's not simply a collection of data that doesn't matter, because data has to be organized and it has to be structured. And these things need to be thought about when a database is designed. So when a database is designed, it's not simply inputting data. There's a lot of theoretical knowledge that goes behind it. So the database has to be designed and carefully thought out using a set of rules, okay? And the American National Standards Institute came up with a theoretical model around 40 years ago. So, and it's based on 3 levels. So when a programmer is designing a database, they have to think of 3 things, okay? So the external level, who's going to see what? The conceptual level, okay? So how is this database going to be split so that it can be controlled, that those on an external level cannot see data that they don't need to see and shouldn't be seeing, okay? Because the database can have a lot of sensitive information. And then you've got the internal level, so how the data is stored, where it's kept. Now, you may recognize this model from the book. Obviously, it would make sense to use the model from the book and nowhere else, okay? Now, so I'm just going to get a stamp tool here. So for example, here we've got the external view, then you've got the conceptual view and the internal level, which is the lowest level. Okay, so it goes 1, 2, 3. And then we've got the physical storage of how it's stored. And what the programmer's done here is the programmer has recognized that the database is going to be physically stored within the disk drives of the building, probably. Okay, so we're working on this using basically scenario that we placed in last lesson. Okay, so the theoretical agency scenario, which was discussed, as you know, last lesson. So now I'm going to go through each of these levels briefly here. So the physical storage is represented as being saved on a disk. We know from last lesson, okay, that they are saving a disk, you know, saving it on a disk as a file. We know that, okay? So all the data's there, but the programmer needs to make sure that in a database it can be read, and obviously it's flexible to change and it's subject to change in terms of flexibility. So now this could have happened with a lot of companies, for example, because as you know, recently the GDPR laws have come around, okay? And basically there's certain things that you shouldn't see and cannot be seen, cannot be shared publicly, and so on. Okay, so we know that this information had to have been changed. Now, what a lot of companies may have done is they may have restructured their databases, obviously to suit the laws of the GDPR and make sure they're following the laws. Now, the lowest level, so it's not the physical storage, it's lowest level, because we know the data is physically stored on disk, okay? But we need the details of the internal level, okay, storage. So this is the lowest level. So where it will be stored, how much memory it will take up, how much memory is needed on a disk drive in future, because a company may grow and they may store more data, okay? Or can the disk physically store the data that is already there, okay? Because we know it's in a text file, and a text file takes up absolutely no memory whatsoever, but a database is going to be quite different. Now, so this is the view, the conceptual view, that maybe in theory is seen by everybody, but not quite, okay, because it's controlled by the database manager, okay? So the database manager is going to control who sees what, okay? Because obviously that no matter what view you're on, so this is the external view here, these are the individual views for both the user and the programmer, okay? So there may be a contact view, all right? So there may be a publicity view, a finance view, and a recruitment view. So these are 4 views, but really the data is all coming from one place, and that is the internal level. But the conceptual level here is the part that is protecting somebody's personal data. So you've got to imagine there's databases in schools, there's databases in police stations, there's databases, you know, in the doctor's surgery, there's databases everywhere. So if you think about this on a personal level in school, the school holds a lot of data about you. Okay, so your name, your date of birth, your address, who your parents are, your parents' bank account details. Okay, your parents' address, because some people's parents live separately. Behaviour in school, maybe if in school you may be attending counselling sessions. Okay, so all this information's being kept. Now, if you was a child that gave some personal information to the school that the school has to keep on record for whatever reason that may be, is it necessary that everybody sees it? You know, is it necessary that your teacher may see this personal information? Well, it isn't, is it? Okay, because someone like me, I'm there to teach you computer science, and I'm there to make sure that you achieve the grade that you need to achieve, and obviously that is your responsibility as well. But is it necessary that there may be personal information about you that I don't need to know, that you would rather keep private, but you feel it's necessary that some people in the school know about it? Okay, is it necessary that I see your parents' bank account details? We're in a private school, fees are paid. Maybe, you know, your parents at some point may have fallen on hard times and may be behind in the fees. Is it necessary that as a teacher that I know that? No, it isn't, okay? So that's why there's all these different views. So for example, if we take our character, Daniela Herbert, that we made up last time, and she's got recruitment have got in touch with her and said there's this great opportunity for you and your band to sing at this amazing exhibition, okay, and they go and look for her on the system. Do they need to see the finance? No, they don't. Do they need to see Daniela's bank account details? No, they don't. Do they need to see how much Daniela was paid last month? No, recruitment don't need to see that, do they? Okay, that's not their job. That's not what they're there to do. Okay, so moving on. What is a relational database? So rather than storing data in one file, where all the information can be seen on one file with several lines of data, okay, and several fields of data, well, we don't need that. Okay, so what they do is that because it gets confusing and disorganized, it's split up into 2 or more tables. And these tables will relate to each other. There will be a relationship that joins them together. Now, if you studied IGCSE ICT, you will know this because you would have made a relational database at some point. Okay, you may not have done it in your exam. You may have done it practice in class. Okay, but the field in that, the data in that field does have to have something in common. All right. So the relationship data will be a collection. Basically, a relational database then becomes a collection of relation tables, okay? So in a database, you will name the table and their attributes, okay, which are basically the fields. Okay, we call them attributes because obviously they are categorized in terms of text, currency, numeracy, and so on. So now, staying with our scenario, okay, so we've got 2 tables here. All right, so this is one table. Sorry, I'm just going to get my spotlight tool here. So this is one table, okay, and that's another. All right, so in this first table is the member of the band. So each member will have an ID, they will have a name, and obviously their family name. All right, and they will have their band name, and then there will be more details, like for example their address, their telephone number. So if an event does turn up on the system for them, obviously they need to get in touch with them. All right, so the agency needs to get in touch with them. Then we've got the band table. Okay, so they've got obviously the band name is the same here. Then there's the agent ID, the agent name, because each of these have got an agent that works with them, the address of where the agency is situated, and their contact number. So then the recruiters can get in touch with the agents and say, hey, I've got an event here, can you get in touch with a member or whatever? Okay, so now moving on. Oh, I need to remove the spotlight tool, sorry. No, it's fine. Okay, yeah, relational to, sorry, let me clear that because that's going to annoy me. There we go. Right, so, let's put it onto some sort of drawing. Mouse and go, thank you. Right, a row in a relational table, as you know, isn't referred to as a row, because if you'd have done IGCSE, ICT, you know that it's a tuple. But this is merely jargon. And the reason why they call it a tuple is because once it's in a relational database, it's going to relate to another table, so therefore it becomes a tuple, really. So it's not an individual record, it's a tuple. And then if we take a look here, so you can see each of these records here, or rows, well, they're records or tuples, okay, you can see as different fields. All right, so you've got one for Daniela, then we've got one for John. Okay, but they will need a primary key, okay, to make a single attribute, okay, unique. So what the primary key does is it will make those values completely unique. So what is a primary key? So this is simply a key field, or we know it as a primary key within a database, which enables each record to be uniquely identified. Okay, so it will ensure that that entity has integrity, okay, to make sure it's not duplicated. Right, so if we had a database of cars, then the number plate, because each number plate is individual, no two cars have the same number plate, okay, but each number plate is unique, so therefore the attribute that you would make the primary key is the car number plate. So you may have the details of the car, which is red. Maybe the car's petrol instead of diesel. Maybe the car is an Opel Astra. Well, how many red petrol Opel Astras are there in Gran Canaria? How many red Opel Astras are there in Spain? Okay, but how many would have that number plate? Well, there would be loads of red Opel Astras, okay, all different years, all different types of car, but only one would have that number plate. And it's the same with your phone number. So if you was to contact Movistar and they was to put in your phone number, the only person that's going to come up is you, and that's it, obviously. Right, so before you move on to the worksheet, I'm going to do a demonstration. Okay, so I'm going to do a new share. I'm going to share my database here. Okay, and this is my database. So I've got two tables in this database. All right, and one is for the band. So I've got the agent's ID, the band name, the agent's name, and where their address is and their contact number. Then for the members, I've got the member ID, the given name, the family name, the band that they're in, and then I've got the agent ID, because those are the two common denominators for the relationship. Right, now, firstly, I'm going to assign the primary keys. Actually, I shouldn't have closed that. So now here, I'm going to make the agent ID a primary key, okay? Because as you know, there's more than one band name. Now, I know in the book it says about making the band name the primary key, but in this case, I wouldn't. And the reason why I wouldn't is because, as you can see, there's three people here in the same band. So why would I do that? Okay. So I'm going to make the member ID here the primary key because it's unique, and I'm going to make the agent ID the primary key because I've made sure that that data is unique. Okay. So if we take a look here, you can see the agent ID. You can see it's A, standing for agent 001, 002, 003, 004. Then for the member, I really do get sick of that noise. I don't reuse access. I've got TA standing for theatrical agency 01, 2, 3, 4, and each individual here has been given their own ID. So that's why I've made that primary key. Right, now I'm going to show you why the relational database is important. Okay, So I'm going to go on to external, no, not external data, create, and I'm going to create a query. As I said, I hate that noise. You hear it all the time. Right. And now if I was to take the members table and drag down the members table, and then I was to put in, like, for example, you've got the band name twice anyway. I want to know who their agent is, okay? So if I was to type in Daniela, and run this query, you can see Daniela Herbert comes up several times. But if we look at the agency name, the agency names are all different, okay? Which doesn't make sense. None of it makes sense. It's completely wrong, okay? So what we would do here, I'm not going to save this, is I would go onto database tools and I'd create a relationship. Now a relationship has to be primary key to foreign key. Now, as we know, the primary key is the unique identifier, but a foreign key is another field in a database that is not the primary key. So the two common entities I've got here are agent ID and agent ID. Now I can make, in theory, I can do this, okay? But it's not going to work because there's nothing in common, okay? So you've got to make sure that they've got attributes in common, okay? So I'm going to do agent ID to agent ID because I've made the agent ID here the foreign key. Okay, so now they've got a relation, all right? They've got something in common. So I'm going to close that, and now when I run a query, okay, it's going to work. So if I go to query design, right, so I'm going to pull down the same fields. And I want the agency name to come up. So I'm going to put in, give a name. So remember I did Daniela. And I'm going to run that. And you can see now only one comes up and our actual agent's name comes up, okay? The same as if I wanted to find out who's in the way out band. There we go, all the members of the way out band comes up and all the same agency comes up, okay? So that's how a relational database is created and that's how it works. Right, so now your task. Okay, so your task is, I'd like you to complete this worksheet. You're going to have to download it on Word, okay? Because it doesn't really work on Google Docs. It just looks messed up because I've made it on Word, and Google Docs doesn't have the same features as Word. So bigger picture, what is a relational database? Stickability, what are the theoretical models designed by the American National Standards Institute, and I'd like you to describe each of the 3 levels. What is the difference between a primary key and a foreign key? And from the demonstration, what did you learn about relational databases? Okay, obviously, like I said, if you've done GCSE ICT, you know it anyway. And if you need help, please refer to chapter 10 in your book. Okay, the database approach section. Right, the very best of luck. And obviously, if you need any help, get in touch with me on Google Hangouts. And this worksheet is downloadable from Google Classrooms, or underneath this video, you can download it directly too.